Okay. Now, so looking at these questions, 12, 13, and 14 from 3.2. Sorry I couldn't get to these last Friday. Um, I guess that's one thing I need to work on is looking at my emails over the weekend to see if I can get to these a little bit quicker. Okay, so here I have number 12 pulled up. The question is to graph the derivative of the function of this function graphed on the right here. Just remember that derivatives are representing the slopes of our function. So if this is the function itself, then as I move along the x-axis, the new y value of the derivative becomes the slope of the original function here. So as I start off, right, the slopes of all of these tangent lines is negative, and then once I get to about the halfway point, now my slope is 0, and then my slope starts becoming positive. You can also think of it as decreasing and increasing. Initially, we are decreasing, but then I hit 0, and then we start increasing. So my derivative is going to start out negative. It's going to hit 0 at about the halfway point, and then it's going to become positive after that. The only one of these choices that starts off negative, hits 0, and then is always positive is going to be choice C here. So my derivative, my slope, starts off pretty big negative, right? If I look here, I have a pretty big negative tangent slope. But as I get closer to the middle of the graph, my slope starts getting flatter and flatter and flatter. So my derivative starts getting closer to 0. At the middle, I do hit 0. And then after that, my slope starts off slow, but then it starts getting bigger and bigger and bigger as a slope, which is why this increases. So that's going to be the answer for 12 here. 13 is very similar. So 13, we have this wiggle graph. Let's look at it first. So as I start off, I have a little bit of a positive slope, but then I hit 0 pretty much right away. So it's going to be a little positive and then hit 0, and then it's going to be negative for a while, hits 0 again for a flat tangent line, and then positive, hits 0, negative, hits 0. So my graph is going to look like, anyway, it looks like it's going to wiggle just like this graph does. So again, looking at a graph that starts off with a positive slope but hits 0, and then a negative slope hits 0, positive, 0, negative, 0. It's got to be this one over here, right? It starts off positive and then it hits 0. It's negative for a while, hits 0, positive for a while, hits 0, negative for a while, hits 0. Now, there's these waves, and that's because of the magnitude of the tangent line. Let's look at this first hump here. After I hit 0, my slope starts off pretty flat, and then I get really, really big negative slope, and then my negative slope gets flat again as I get closer to 0. That's why it has a hump to it. Flat negative slope gets to a pretty big negative slope, and then it flattens out again before it hits 0, and then it becomes a positive slope. So that's how that one works. I think there was one more, 14. Again, very similar kind of thing. So this one, you're actually finding slopes at particular points given this curve here. The first question it wants to know is, it's just kind of a multiple choice here. Choose the correct answer. So we'll just go through each of these. The derivative is not defined at -4, 1, and +4. So we do have to be careful about that. For derivatives to exist, they have to have the same derivative from the left and from the right. So if I'm here at -4, I don't have a left derivative, so it doesn't really make sense to talk about the derivative there. Same thing at 1. At 1, the derivative on the left is a big negative derivative. Derivative on the right would be 0, so it wouldn't make sense there. And then +4, something very similar is going to go on. Now, the way that we have to be kind of careful with it is at these end points. Usually at the end points, we just say that yes, the derivative is defined. It's just whatever the left or right one that exists. So just looking at this graph, it looks like we are not going to have a derivative at 0 because the left and the right do not match, at 1 and at +4. So those are going to be the three choices that we choose there. 0, 1, and 4. The endpoints will just say the derivatives do exist, although some books will say they don't. Then it wants us to graph the derivative. Don't forget that the derivative is just the slope. From -4 to 2, it looks like we have a positive slope. From 0, I said to 2, sorry, from -4 to 0 on the x-axis is a positive slope. From 0 to 1, it's a really big negative slope. From 1 to 4, it has a slope of 0. And then from 4 to 6, it has a positive slope again. So just picking the ones of these that would match here. -4 to 0, it's a positive slope, so it can't be that one because that's negative. The others are fine. From 0 to 1, it's a big negative slope, which it looks like all of those have that, right? 0 to 1, 0 to 1, 0 to 1, 0 to 1. They're all down here at a big negative slope. From 1 to 4, it's at 0, which means this one can't be true. So now it's either A or it is D. And then between A and D, the last little bit here is that from 4 to 6, it's a big positive slope. So from 4 to 6, it has to be this one, the positive slope, not this one, the negative slope. Okay, so yeah, derivatives just represent slopes. All right, there was one more thing here too. Can I also get number 21 from section 2.1 explained? And yes, so let me pull up 2.1. I hope you didn't mean 3.1. Let's see. Well, how about this? I'll just put this video up for these three, and if it is 3.1, just let me know. Let me see if this one has interval notation, and then maybe we can look at it. Oh, it does have interval. All right, maybe you were talking about 2.1 here. Okay, let's look at this. Find the average rate of change of the function over the given intervals 2 to 4 and then -1 to 1. So average rate of change stuff, remember just using the formula. It's f of b minus f of a over b minus a. So if we're going from 2 to 4, that means my a is going to be 2 and my b is going to be 4. So we plug 4 into this function minus plugging 2 into the function divided by 4 minus 2. All right, so that's all there is for average rate of change. Let's see if you did mean 3.1. Maybe there's interval notation on number 21 of 3.1. There's not even a number 21 for 3.1 yet, so it must have been the other one. Okay, so yeah, all that interval means is that we're going from 2 to 4 on the x-axis. So x equals 2 to x equals 4, and that's going to be your a and b.